Hello, everyone. Good evening. Welcome to the SKYWARN spotter training for 2021. My name is Matthew Foster. I'm a meteorologist for the National Weather Service here in Honolulu, and I've been here about 12 years. So it's been a while, and I've been giving these talks for probably about half of those, or about 6 of those years. So we'll get started then. So here's our presentation outline here. First, we're going to be talking about just an overview of our office, and then we'll get into the Central Pacific and Hawaii weather patterns. Then we'll talk about what to look for out there in the field, safety, how to be safe, how and what to report, and then, of course, what you all been waiting for, how to sign up. All right, so the National Weather Service office consists of a number of different forecast offices, 122 across the country. You can kind of see the map there. And then we have 6 regional offices, which those are kind of outlined in those colors there. We have Central Region, the Eastern Region, et cetera. We have 8 national centers. You probably are most familiar with the National Hurricane Center, Storm Prediction Center, Ocean Prediction Center. So those are kind of our national centers. Interestingly enough, our office is very unique where we take some functions of those national centers and sort of incorporate it into our office. So we're the Central Pacific Hurricane Center. So we're handling the same thing NHC does, except in another area. And then we also have some river forecast centers, 13 of those across the country. So here's our office. What we do is we forecast the weather for the state of Hawaii. That's probably the most public and part that you guys see out there. But we also do forecasts for airports, aviation, and aviation routes across the Pacific. You know, Hawaii being a very isolated island chain that we would have to, you know, aviation is a big importance, and they need to know the types of weather patterns, you know, not just in Hawaii, but over a much greater area. We're forecasting winds and waves for the ships and any kind of commerce that comes across the water for the Central Pacific. Again, they need a much wider area to work with. Of course, with a hurricane center, so we're forecasting hurricanes across the Central Pacific. We also do data gathering, quality control, and climatology. So as I mentioned, the areas of responsibility do vary quite a bit based on what we're doing. So if we're just forecasting, our public forecast would just be for the state of Hawaii, just be in the green there. But when we're talking about our hurricane center, we're going from 140 west to 180 and anywhere north of the equator. We also, for the marine forecast, we have a big area also in the southern hemisphere that we're watching. So in addition to 140 west to about 160, 155 east. And then our aviation forecasts is in the yellow box there. Those almost go to 130 east, almost to the Philippines there. So big, large area that we're focused on. So it's not just Hawaii. All right, so now we'll get into the weather patterns. We have our 6 basic weather patterns we deal with in the islands. Is we have trade winds, we have a convective pattern, which would encompass daytime sea breezes, nighttime land breezes, an upper low or trough, cold front or shear line, Kona low, and tropical cyclone. All right, so trade winds are driven by this feature called the subtropical high. It's a feature that sits around 30 north. It moves around a little bit, but generally it's there roughly in that same latitude. So you could think of high pressure systems as a big pile of air that it spreads out in a clockwise manner due to what's called the Coriolis force. I won't get too much into the physics and everything, but just note that the Coriolis force bends things to the right, and if we think of the air diverging from that high and to the right, as it does that, our winds generally are going to be out of the east or northeast, depending on where the position of that high is. But it's fairly persistent. So the time of year varies. Like I said, that feature is there most of the time. In fact, in the summer, 90% of the days you could think of as trade wind days, where that high is persistent in that first image there. The second image shows wintertime, where we get more low pressure systems coming in and moving that high out of the way, moving it off to the southeast there, and then we just get more variable type winds. So you can see in January, about 50% of the days would be considered trade wind days. And then it's almost like a bell curve, where we have kind of the peak in the middle of the summer, and then the least amount of time with trade winds would be right in the winter time. So it's almost like a bell curve throughout the year. So what does this high do? Well, I want to compare two areas. The Bay Area, where we have which is right about 30 north, near that high, and comparing the type of weather between both of these. So what I'm going to introduce to you is a concept called a temperature inversion. So normally when you go from the surface on up to space, temperature decreases with height. It gets colder. You get the radiative heating from the sun. You get further away from that, you start to cool. But what the high is going to do is it's like, again, it's a pile of air, but it's also sinking, and that gravity compression from all that air coming down from above, pushing on that material, creates heat. It warms the environment and creates this inversion. So that's important because any kind of heating that occurs at the surface and makes the air parcels at the surface buoyant, they're going to lose their momentum, because they're going to now, instead of being warmer than the environment, they're going to be colder than the environment. So these images here show balloon sounding. It gives us a vertical profile of the atmosphere. So the line on the left and the line on the right indicate the dew points and the temperatures respectively. So when our temperature and your dew point are close together, which you can see trapped below 500 feet there in on the Oakland sounding, well, when our temperature and dew point are the same, we're 100% humidity, we have clouds, but it's all trapped in this very shallow layer. And then when you get above that, the dew point and the temperature spread out quite a bit, and then you're clear. But that cap, you can see where on the temperature where it raises quite a bit, and that layer just above 500 feet. Well, that's gonna any kind of heating at the surface is going to be any kind of parcels that are heated at the surface aren't going to be able to break that cap. And plus, the water is really cold in that area, so it'd be really hard. It's a very stable regime. So if we go over to the Lihue sounding here, where you can see that it's a little bit higher up, it's about 7,000 feet. That's fairly normal, about 6,000 to 8,000 feet. Then there's a weaker inversion, but there's still, because Hawaii is surrounded by ocean or dominated by that, by the temperature of the ocean, it's really hard for us to heat up enough just from the sun and daylight to break that cap. So long story short, we're going to have clouds and showers kind of limited in that below 7,000 foot level most of the time with trade winds, and it can vary a little bit, and it can weaken and strengthen, but generally our clouds are going to be limited to that. And you can see the I'm not sure which mountain that is, but some of our topography sits above that layer. So local considerations, again, topography is going to play a big role. 50% of the land is above 2,000 feet in Hawaii, so it's going to have a big impact on our weather. And it's also in the case with this image here, where you see the wind kind of tracking through the Central Valley there of Maui, it's going to sort of divert the winds as well. So as the air reaches the islands, as the wind reaches the islands, it's going to go over this large fetch of ocean driven by that high, thousands of miles, and all this evaporation is going to be occurring, and so it's going to be fairly moist as it reaches the islands, and then it's going to get lifted by the mountains. The air is going to be cooled as it's lifted from higher pressure near the surface to lower pressure near the mountaintop. That air then becomes saturated just from the act of lifting it and cooling it. That's going to create condensation, water droplets, rain, and that's going to favor the side of the island that the wind is coming from, or the windward side of the island. Then the air is going to come down. All that moisture has been now wrung out on the windward side, so it's going to be drier, and then it's going to be warming as it's coming down the mountain. So that's where the rain shadow occurs. So all the moisture wrung out, and then once it reaches the mountaintop, and then the drier air continues on down the mountain. So we can see this in our annual rainfall. If we look at, because trade winds are so dominant, we can see the trade wind pattern right in our climatology. So like on Kauai and Oahu, the Kolaus, the mountains there on Kauai, they catch most of that rain from the windward side. And then on Kauai, so back there near Kokee State Park and Waimea Canyon, still pretty high elevation back there. So there is a bit of a drop off from Mount Waialeale, but it really doesn't start to get the rain shadowing effect until you get down at the low elevations near Keikaha, Barking Sands area. Similar on Oahu, you have Waianae, Ewa, really dry. You have the maximums occurring on the Kolau Mountains, and then another maximum there where you're getting some lifting, also provided by the Waianae Range. The air is a little bit drier once it gets over there, so that's why it's not quite as wet as the Kolaus. All right, so this is a visible satellite image showing a fairly dry trade wind pattern. This is just my assessment based off the texture of the clouds. These are more stratocumulus type clouds. They aren't going to be producing a whole lot of rain. And you can kind of see, especially on windward Maui there, where you kind of see the clouds really banked up against the lower slopes of Haleakala there. So pretty much a pretty solid inversion that's keeping those clouds at just anchored against the mountains at the low levels. Even though we see less clouds in this satellite image, it's actually more a wetter pattern, just because there's more up and down motions in the atmosphere. These are more cumulus type clouds, more showery type clouds. Strong trades by themselves don't really cause too many problems, just because that's the most common wind direction for things. But usually what happens is either that subtropical high gets really strong, and just the pressure gradient between the equatorial low and the subtropical high is just really tightly packed together, and that's just causing those winds to strengthen. The other thing could be something like a trough, or even a tropical cyclone passing south of the islands. That would create that tighter pressure gradient. So that's what I kind of mean, pressure gradient in terms of differences in pressure between the high and the low. Impacts wise, not usually just you get more showers kind of coming up over the mountains onto leeward sides, resulting in maybe a little bit more uniform rainfall distribution. And then usually the climatology that I just showed you for Kauai and Oahu would really not be impacted too much by a strong trade wind pattern. All right, so that's it for trade winds. I don't see any questions here. So again, if you guys came on late and you guys got any questions, just open the chat room, type it in, and I'll periodically stop for that. Okay, so moving on. So next is a convective pattern. So convective pattern is basically means heating. So we have, you probably heard the term sea breeze, land breeze. Sea breeze meaning the wind is coming from the onshore, and then land breeze meaning it's coming offshore from the mountains to the ocean. This occurs on all islands when the trade winds weaken. I kind of put that in quotes because some areas around the, not all areas around the state are created equal. Some windy areas, think places like Makapu'u, where it's windy all the time there. It would have to take pretty much a high to sit right over us for them to see this convective pattern take over. But for more protected areas, Honolulu, places like that, you would say when they weaken, once it starts getting below like 7 or 8 miles per hour, we start to see this pattern take over, and we can see evidence in the cloud patterns and radar coverage, just where the showers are setting up. So what this means is we've got it's a heating thing. So important to point out here is that cold air is more dense than warm air. So if we put cold air and warm air next to each other, the warm air is going to be buoyant. It's going to be less dense. So when the incoming solar radiation from the sun starts in the morning, starts heating the land is going to heat up faster than the water. Water has a very high specific heat. It takes a lot of energy to change the temperature of the oceans. So the land is going to heat up faster, and that's going to heat up the air surrounding it, and so that air is going to be warmer relative to the water. So that air is going to rise because it is buoyant, and then it's going to lift, and that's going to create this pressure deficit at the surface over the land, and that's going to be filled in by the higher pressure, the relatively higher pressure over the ocean, and it's going to move inland. So it's going to move from the ocean over land. And then it's going to start traveling up the mountains as well, because it's going to be continually pushed up, by the air behind it. So it's going to go up the mountains. So we've got two things. We've got the heating that's providing the lift. We've got the mountains that are providing the lift. And then we also have convergence. So a sea breeze on the north shore would come from the north, and a sea breeze from the south shore would come from the south. They would converge somewhere, usually in the center of the island, and that would also, it's got to go somewhere while it goes up. So those three processes keep it going throughout the day, as long as the solar radiation is coming in, as long as the sun's up. So that lift is going to given the air mass and what kind of conditions we're dealing with, as you can kind of see from the image there, that uplifting of air is going to create clouds, showers, and depending on how much moisture is in the air, result in more showers. So in conjunction with, say, an unstable environment where these clouds can grow taller and taller, associated with an upper-lower trough, the showers could intensify or maybe grow into thunderstorms. So this afternoon visible satellite image shows where those clouds are forming over the island. So you can kind of see Kauai is completely cloudy. You can kind of see the Waianae a little bit, the Kula portion, Ulapalakua area on Maui, and then pretty much all of the Kona slopes and the Kau area on the Big Island. So that's a pretty typical sea breeze afternoon statewide. So the land breeze, pretty simple. All this is going to reverse. The land is now going to cool faster than the ocean, and that air is going to now come down the mountain out to the water, and that sinking air that is going to suppress any clouds and showers, essentially ending the circulation that was set up earlier and reversing it. So the air has much more, you can kind of see the satellite image here showing, pretty much a clear morning. So the air doesn't really converge so much over the ocean, just because it has a lot more area to spread out into. So you don't really see like the organized, localized stuff that you see over the islands during the day, because we're small islands, big ocean. So that typically what it would look like. Generally, we would see clearing skies over the over the islands throughout the night under a land breeze. All right, so now I've talked about the two main weather patterns here, and those are kind of well, actually, I'm not done with this. What I want to do is mention here in this image here where you've got this yellow dotted lines here kind of show the leeward side of Haleakala there and Mauna Kea, Mauna Loa. These areas are going to be blocked by the trade winds in pretty much all situations. So we have our mountains here, and I put the elevations there to show you that that's going to be higher than the normal inversion. Now, I'm not saying that the inversion can't get up to 10,000 feet or 12,000 feet. It certainly can, and they will get precip if that happens. But most of the time, the mountains extend above that normal inversion layer. So it's going to block these areas that are downwind from them. And then, so you can kind of see in the orange arrows there, kind of showing the air instead of going up and over the mountain, now that inversion is going to block that, and it's going to have to diverge and go around the island. So you can kind of see what's happening here is as the trade winds approach, they split and they go around the big island, and then essentially the Kona side is blocked from that easterly flow. Also want to point out here on the red circle here, this is a little bit of a dead zone where the winds have split. And because areas like Hilo, Lepahoehoe, those areas are kind of right in that area where it splits, they will also see a convective pattern on most days, even when the trade winds are blowing. So here's an example here of afternoon where you can kind of see the prevailing wind direction, with the clouds kind of anchoring over the windward side. So on the leeward side, what's happening here is the sea breeze is setting up because, again, it's blocked by the mountains are blocking the trade winds. You have the cooler ocean, you have the warmer land, higher pressure, lower pressure, you're going to go, it's going to be a westerly wind onshore. And you can kind of see where the clouds are pushing up as they're pushed up the mountain. You can get a pretty good indication of where that inversion layer is, depending on how high they go up the mountain. So that's why typical afternoon on the Kona side of the Big Island, you'll see increasing clouds about middle of the day, and then maybe get some showers and throughout the afternoon, and then that process reverses and it clears out in the evening. Okay, so we can see that in the rain patterns here or the climatology, the rain climatology for Maui County and the Big Island. You kind of see most of the rain on Maui here forming the West Maui Mountains, kind of the highest point getting the most rain, but on Haleakala it's only about the mid slopes there, maybe about 2/3 of the way up there where you see that 340 line. And then once you start getting higher than that, it starts drying out. Similar on the Big Island, most of your rain, the highest amounts of rain are definitely on the windward side, but then it starts drying out when you get higher in elevation. Then there's also some maximums here on the Kona side, pretty low, a couple thousand feet up, and then also in the Ka'u area. And again, both of those are going to be due to those afternoon sea breezes. So the time of day that they get the rain is also different. Hilo gets most of its rain during the night. Kona side, Ka'u area gets most of its rain in the afternoon. All right, so next pattern here is the upper low or trough. Basically, they mean the same thing. It just the low is just a closed circulation aloft, but essentially they are a cold pool of air aloft moving, over the area. What that's going to do is, remember I said it was hard to break that inversion in Hawaii just because we're so moderated at the surface with the ocean temperatures, but we can break that inversion. We can get rid of it if we get some kind of cold pool coming down and eroding that inversion. So this would be a situation when we get an upper lower trough over the islands that's going to create an unstable environment. it's going to reverse that sinking motion driven by that subtropical high. It's going to allow for rising motion to take over. And then it's going to enhance the low-level features of what's going on, whether it's trade winds or sea breeze-driven showers. They could be completely independent of what's going on. Weak troughs can have little influence. You know, like in the summertime, we will typically get a relatively weak upper trough, but because the trade winds are so persistent, we really don't see much enhancement at all. Maybe just maybe a few more intense trade wind showers when it's focused over the islands. But weak troughs can have little influence, but stronger ones that build down to the mid layers and down to the surface can have pretty drastic influences on our weather. I thought if it's in that situation, we could get heavy showers, thunderstorms. They tend to be active lightning producers when they do form. So I mentioned trade winds. The trade wind pattern at the surface with an upper trough over us will result in a relatively similar rain coverage that's similar to the climatology. So in this example, we have an upper trough over the islands. We have trade winds blowing at the surface. The overall weather pattern, the radar precip coverage is going to look similar to where the coalows are catching most of that rainfall. Higher inversion might mean that more of those showers are going over the mountaintops onto leeward sides, but overall this should be a fairly wet windward side weather pattern for rain. Again, leeward sides could get some rain out of this, but not as much as the windward sides. Okay, so then when we get an upper trough with a convective pattern, so now we have weak winds, and a lot of times these may be related. We may have an upper trough that's bringing a front towards us and weakening our winds, and then we're stuck with a convective pattern with an upper trough over us. So a lot of times these happen together. It's not a coincidence. But so essentially we have that cold pool aloft over us, and then we have weak wind flow at the surface. So the instability provided by the trough is going to allow for greater vertical development of clouds, and then the lack of trade winds is going to mean that those updrafts that form those clouds, those up and down, the upward motion, downward motion, are going to be less disturbed. So you can think of trade winds as a wind that's moving parallel to the surface of the earth. And if it is not present or very weak, your up and down motions are going to be less disturbed by that. So they're going to essentially allowing them to be more organized. So that can result in stationary heavy showers or thunderstorms, or very slow moving ones, or ones that just kind of meander around. They don't really have anything to really push them along. And so this causes problems with flash flooding, lightning are probably the two big hazards for us. Less common would be here in the image where we have a water spout, land spout, funnel clouds, small hail. We occasionally, a few days a year, we will get that. On very rare occasions, we would see a tornado or like a severe hail size, 1 inch or greater, or meeting our wind criteria, severe thunderstorm wind criteria of 58 miles per hour. So all those ingredients coming together would be hard. I'm going to touch on that here when we start getting into what to look for and the stuff in the field guide. All right, so the next event, okay, I don't see any questions here, so I'll move on. Cold front. This is going to come from the mid latitudes, from the north. These are, you can kind of see the image there. A lot of times we're on the tail end of a front. It's not really going to be a very drastic air mass change. Usually most people around here, if they have a cold front goes by, they'll usually notice that the air is much drier. We'll usually see a pretty I don't know, maybe 6-7 degree, maybe 10-degree drop in dew point, and that, because our dew points are fairly consistent here, it may be a day or two where it just feels dry, and that's where it kind of feels a little chilly. But they're generally weak. We're not going to have a very strong temperature contrast across them. But sometimes we can get strong fronts that can be significant weather producers. They're often in the process of slowing and weakening when they reach the islands. And then sometimes we will have a front completely dissipate, and then the trade winds will kick back in, and then they'll push that upstream moisture from the dissipated front back over the islands. And it's just a loose band of showers from a dissipated front, and it just produces several days of kind of more nuisance type rain. So we call that a shear line. All right, so this image shows a infrared satellite. So infrared, we're looking at cloud top temperatures. So when you see these oranges and yellows, we're looking at higher cloud tops, colder cloud tops. So this would be, but the cold front is a surface feature. So the cold front actually, you see up to the northwest there where the oranges and the yellows, that's obviously going to be enhanced by an upper level trough. You can kind of see that U shape there, but the front actually extends out to the southwest here, and with these more shallower type clouds. So something, like I said, not all fronts are created equal. If we're on the cusp where we might get hit with maybe the more shallower part of the front, maybe it might not be too bad. If we're going to have a upper level trough over us at the time this moisture gets to us, it could be a worse situation, All right, so as a front approaches the islands, we're going to have a wind shift. So the winds are going to go first out of if we have trade winds or out of the east, they're going to start swinging around to the southeast, south, and as the front goes by to the west, northwest, and you'll be able to kind of see it on this animation here, where it just shows a front moving across the state. Not a fairly benign one here, maybe 7,500 mile wide band of clouds, moves through pretty quickly. Probably not producing a whole lot of rainfall, but you can see on ahead of it, as the front is approaching ahead of it, the clouds are moving south to north, kind of east of the Big Island there. And then behind it, you can kind of see the clouds back here behind it moving into Kauai there are out of the west. Just generalize that from the cloud motions. So just showing you the wind shift there. So annual cold front passages per year. This Kauai, Oahu being further, Kauai being the furthest north, gets hit with the most. And then of course some of these don't make it all the way down the island chain. They dissipate, or the trade winds come back in and push it back to the west. So the further south you get, the less frequent they become. Sometimes the front itself really isn't so much the problem, it's kind of the prefrontal environment. So in this visible satellite image corresponds to the surface analysis. So what we have here is, you can see this front off to the northwest, and then we have this other front, this other dissipated front. There's a trough here, and that moisture is kind of hanging out without any near the Big Island and Maui there, with pretty much the high cut off from moving those clouds anywhere because of that trough. So this would be a classic case where prefrontal environment, where we have moisture in place left over from an old front, and then that's going to be like a classic convective pattern day. And then yeah, this would be, so this is well before the front's maybe 600-700 miles to the northwest, but this would be influencing us indirectly, giving us a convective type weather pattern. And then with the moisture in place, allowing for maybe some heavier showers to develop. When we get southeast flow ahead of the front, this kind of sets up a special orientation where the winds are parallel to the island chain. And so this would be the situation up until 2018 where we would get VOG from Kilauea coming up over all the islands just due to the wind flow. And then, but that's cut off, or that has decreased quite a bit since the eruptions in 2018. We really haven't had at least any days, to my recollection, up near Oahu. And from people I've talked to on the Big Island, it seems like it's let up, or it's tapered off quite a bit from pre 2018. But the other pattern here, or the other issue to take note of is again, the winds are going to diverge around the Big Island and converge on the leeward side, and you can kind of see evidence of that of these clouds that are coming off Apollo Point there, and even off of Molokai and off of Oahu. So if we get the right wind direction and those showers are again diverging and converging on the leeward sides of all those islands, we can set up where we get like a continuous stream of clouds and showers that are training over the downwind islands. So coming off Molokai, we call it the Molokai plume, but a lot of these will, if it just sets up right wind direction, it'll come off of Molokai and it'll go right up the spine of the windward side of the Ko'olaus, and it'll just pretty much keep the rain there for 12 hours, 18 hours at a time. So that's kind of worst case scenario, but yeah, this is just kind of one of those old nuances about I mentioned the topography having a big influence on our weather. This is just one of those cases where, and also keep in mind too that when the wind direction shifts out of the southeast, there's much more deeper tropical moisture that comes from the south, and if we just sort of if it gets pulled in and far enough north over the islands, that could be a situation where it just it can bring a lot more moisture over the islands, and then add it to the topographic effects. So we've even had situations where like tropical cyclones are passing south of the islands, but then the direction, just the tip of the very northern end of it, the moisture kind of gets caught up in that and moves over us. All right, so still no questions. We'll move on to Kona Low. We just got 2 patterns left, and then we'll start getting into the good stuff. All right, so Kona Low, this is we're kind of going from most common to least common. So Kona Lows are develop in the trade wind belt. So fronts develop in the prevailing westerlies. Tropical cyclones develop near the ITCZ, the equatorial low. That's where the southern hemisphere and the northern hemisphere trades converge. So I kind of have a satellite image there of that. And so the atmosphere near the equator is the deepest, or is the highest anywhere on the planet, and then it gets shallower as you get towards the poles. So the thunderstorms and showers that surround the tropics there, those are pretty much more moisture can get put in that in that deeper layer than anywhere else on the planet. So the Kona Low, what that's going to do is tap into that moisture and drag it pretty much to our latitude. So what we have here is the intertropical convergence zone there right near 10 north, or about 12 north here. Hawaii's not on this map. This is just kind of showing for example. So again, we have infrared imagery. We're looking at thunderstorms being pulled up to the north out of this this line that's right around, like I said, 12 north, and drug all the way to around 20 north. And so these Kona Lows don't really move. That they kind of wobble, or maybe have a tendency to move slowly westward when they form. But they're very efficient at dragging a lot of moisture over the island. So if you guys remember, if you guys were around in 2006, this was the part of a cause of the 40 days of rain on Oahu. Had a Kona Low set up for a portion of that. But these are very wind direction would be the same or fairly similar at the low levels as well as the high levels. So we can get pretty strong winds, and then also very strong winds at the summits or anywhere kind of along the mountain peaks. Thunderstorms, potentially severe, could also occur. We average around 3 to 4 across the North Pacific each year. So not all that common, but and again, they can have erratic motion, and depending on where the models don't really, our weather models don't really do very well with them, because it's got to pinpoint where that low that's kind of controlling it is set up. And if it's in the wrong, if it's just set up in the wrong place and it's 100 miles away or 50 miles away, it could mean a pretty big difference in weather. So these are tough to forecast, and yeah, like I said, they can have pretty big impacts. So definitely something to keep a watch out for if we get set up with a Kona low pattern. All right, so lastly here we have the tropical cyclone. So tropical cyclone is a generic name. It can mean hurricane, tropical storm, tropical depression, typhoon, cyclone, as they call them in the Southern Hemisphere. So it's just sort of the generic catch-all name for that. And we average around 4 to 5 annually in the Central Pacific. So that's in our area of responsibility. So we're talking 140 west to the dateline. Direct hits to Hawaii are rare, but they have been devastating. We had Dot in 1959, Eva in 1982, and of course Iniki in 1992. We've definitely had some scares, and we've had, in this case with the image there of Hurricane Iselle, hit the Big Island as a tropical storm in 2014. And then I think we had another one, Darby, on like 2016. So we've definitely had some impacts, but we haven't had like a full-on, Category 4, which is what Iniki was, across one of the islands. But certainly a couple years ago with Lane, we were definitely threatened with something like that. Okay, so our season runs from June to November, so it's just about to get started. A third of them that develop into a tropical depression, that's kind of the minimum strength. A third of them will eventually reach hurricane strength. The primary driving factor for development and maintaining is 80-degree ocean temperatures or higher. Here's the breakdown by month up until 2020. So you can kind of see our peak is August, with kind of July and September kind of being the shoulders there. June, we actually just had Douglas last year. That was in June, so we just upped that from 1 to 2 there over the last 50 years. And then some of these ones that have gone outside hurricane season, like December, January, those are just kind of more active years, and they kind of hangovers from that. But spring is usually not much going on. If we break down by year, you can see that some of these ones that stick out here, like 1992, 82, 2015, primarily those are going to be El Nino years, warmer than ocean temperatures in the Genesis zone. Then where you see the 1s and 2s, those are more La Nina, or colder than normal ocean temperatures in the Genesis zone. So this was 2019. We had no impacts. We had Eric was the strongest one that came into our area, but Flossie was the closest to our area. But again, that was just wasn't very strong by the time I got here. In fact, it was just a remnant tropical cyclone at that point, by the time it got to its closest point. 2020 really just had the one scare there. So 2020, we had Douglas in June, I mentioned that. And then we had a, oh, I'm sorry, I made a mistake. The June storm was Boris, that was the first one. Douglas was actually in July. But so the number did go up by 1, but it wasn't for Douglas, it was for Boris. But so Boris just came across across 140 and then dissipated, and then Douglas was the one that came by pretty close last year. But relatively quiet year overall. Started as ENSO neutral, meaning that's the El Nino Southern Oscillation, started as kind of neutral and then transitioned to La Nina, which is generally a suppressive time for tropical cyclones for us throughout the summer. And the Douglas did come close enough where it prompted a hurricane warning for the smaller islands and then a tropical storm warning for the Big Island. And then yesterday, we just released our 2021 seasonal outlook. We are forecasting 2 to 5 for this year with an 80% chance of near or below normal number of storms for the year. This is, again, just to remind you, this is not a forecast of landfalls. This is just overall just activity in our entire basin. And remember that it can only take one to impact us, and we could kind of see evidence of that with Douglas last year. So the main points here: El Nino is not forecast for this year. The sea surface temperatures in the tropical cyclone genesis zone are expected to be below normal. So those two factors are working against it. That's why we kind of went with slightly below normal. So our normal is 4 to 5. We're going 2 to 5. So those 2 points there are working against it, but then we also have this active phase of the decadal oscillation that's maybe helping out a little bit. And to kind of illustrate that is where you kind of see these black lines, which kind of shows the more general patterns between El Nino and La Nina. So when we're going La Nina, we're thinking anomalously cold. We're going to go on the low end. Near normal would be our 4 to 5. Anomalously warm, we would say something like 6 to 7. So if we're going 2 to 5, thinking that's going to be La Nina to normal. So that was kind of the reasoning for those numbers. Mentioned the tropical cyclone genesis zone. Most of our storms come from the Eastern Pacific. So the Eastern Pacific's a little more active than our area. Warmer waters down there. So usually they form in this area and then they come out in our general direction. We tend to have cooler waters near Hawaii, not really active, but occasionally we can get one formed. Atlantic, obviously, last year was a very historic year. They have the tendency to be more active than us as well. And then the West Pacific also, very warm waters out there. They can pretty much get typhoons any time of year. So tropical cyclone impacts, storm surge, those would be where the wind is sort of pushing that the ocean water onshore, moving it into areas where that's normally not covered by water. So storm surge, just due to the strong winds created by the tropical cyclone in the immediate area, and then also the fetch created from upstream as well. There's also wind. Obviously, that's the thing that gets the most attention. Is how strong is this hurricane? How strong are the winds? So that's the Saffir-Simpson scale. They're going to tell you the maximum sustained winds of the tropical cyclone. And you can see the breakdown by depression, storm, and categories 1 through 5 for hurricanes. Probably our biggest impact to Hawaii with these things would be the intense rainfall and flooding. We're just very susceptible to, just because of our topography and just how the topographic influences are, create areas where it just catches the water very efficiently, and then other areas that don't get as much. But yeah, intense rainfall, flooding certainly would be an impact for us. Last 3, it just meant just thunderstorms, tornadoes, generally less of a threat, I would say, than the first 3. And then going back, and then the surf. The surf is the only impact that would really be from a distant tropical cyclone. So we can get some indirect impacts with that as well as direct impacts. All right, so don't see any questions here. So we'll move on. All right, now we're going to start getting into the more of the kind of what to look for as a spotter. And if you guys have any other questions or whatever about the weather patterns, just feel free to drop them. I can always go back. All right, so for thunderstorms, we have, this is kind of the basic diagram is we have, you know, the developing stage where towering cumulus are developing. You can kind of see the little pink line there showing you the freezing level. It's gonna be important for ice in the cloud because that's how you get lightning and thunder. So then the cloud goes taller right into that, you know, well into the ice making phase. That's the mature phase. And then the dissipating phase is where essentially the downdrafts engulf the updrafts and then the storm dissipates. I kind of want to point out these 4 attributes here is moisture, lift, instability, and shear. So moisture, that seems like the obvious one. If the more moisture you have available, the more you know, fuel for thunderstorms you can get. So that we usually don't have a problem getting in Hawaii. We're a tropical environment. We have a lot of moisture. We're surrounded by an ocean. We have a lot of moisture. Lift, most of the time that's the mountains that provide the lift, but fronts can provide lift as well. So usually that it would be you know, some kind of feature coming down that's causing that, like I said, a front, or it could just be the mountains. It could be the sea breeze convergence that's causing that. So usually we have the mountains that are providing that. So the thing we're usually lacking in Hawaii is the instability. We're stable under the trade winds, and the clouds are just not able to grow to be tall enough to produce thunder and lightning. So thunder is a result of lightning, but lightning is produced by the differences in charges, the static discharge when the ice, the static electricity caused by the ice. So you're not going to get it at the, you know, on the low level clouds that are in the first stage there. You're going to get it when the charges are separated and you've got all the static electricity built up. So you can't get thunder without lightning. So the instability is usually the limiting factor. So we usually need some kind of upper low or trough coming down to destabilize the atmosphere and allow any kind of air parcels at the surface to lift up and continue to, you know, to lift up to the high levels of the atmosphere, above 40,000 feet there. And then so shear is kind of the last thing. And what shear is going to do is it's a turning with winds, or it's a change of wind speed and wind direction with height. So as you go up in the atmosphere, you have a turning of the wind. That's going to create these that's going to separate your updrafts and your downdrafts. So if you have a high shear environment, your thunderstorms are going to be able to thrive because your downdraft caused by the rain and your updrafts caused by the, you know, just the instability are going to be separated, and it's not going to kill itself by raining right on top of the updraft. So having all 4 of these ingredients together, this would be and I'm going to talk a little bit more about this when you start getting into hail, tornadoes. But let's just kind of talk about the basics with the thunderstorm. So we have the ordinary cell. That's kind of the diagram I just showed. Single cell, the downdraft engulfs the updraft in the dissipating stage, and it goes away. A lot of times it's not that simple. You might have a pulse thunderstorms where you've got these stages that are going up and down, and then it kind of the environment, you know, as the system is moving along, then then there's other stages that repeat nearby, and then the process starts over, going from developing, mature, and then dissipating, you know, as the system moves. Sometimes we're going to have multicellular clusters. These are where you have different stages going on at the same time. You can have, you know, developing and dissipating going on, and you've got, you know, a larger, bottom line is you have a much larger complex of storms that you're dealing with. There's a lot more going on. So that can be, you know, definitely something to watch out for too. Is it just a single pulsy type thunderstorm, or is it one that's just sort of a part of a larger group of thunderstorms that are you know, disorganized, but a lot, you know, that are going on, that are forming and dissipating, you know, kind of all at the same time. Then if we have something that's a little more organized, like you have a well-developed line of thunderstorms, this would be a multicellular line. This would be like a derecho, bow echo, these types of, you probably heard these terms before. It's more like for, you know, I mean, they can talk, you know, the TV guy can get on there and kind of talk about it, but it's more just looking at the radar signature that the storm is producing. But yeah, this would be like like I said, an organized line of thunderstorms. And then finally, the big one would be the supercell. So usually that's kind of a separated storm from the rest of it. It tends to kind of have a different storm motion than maybe the rest of the line. And these are usually the ones that form tornadoes. So if you see a supercell, keep watching it and maybe it'll drop a tornado. All right, so thunderstorms around the US, you know, we don't get that many in Hawaii. We're definitely surprised. It makes pretty big news when we do get thunderstorms, but you know, we're definitely not on par with Florida or the Midwest or the South. We're pretty much like the West Coast. This image is just kind of showing you the number of thunderstorm days throughout the year. So you see, well, not that many. We're in the single digits except for 10 on Kauai, so just on average. All right, so now let's getting into some of our storm structure. All right, so first one is a cumulonimbus cloud. This is essentially a thunderstorm cloud. The storm tower is going to be kind of the main body of the storm. So now we're kind of dissecting the cumulonimbus cloud and go, okay, this is the part that's having where the updraft is. This is where the main body of the storm is. The anvil is going to be this relatively flat portion of the thunderstorm located at the very top, and it's kind of arches out, and usually what that's indicating is you have the winds aloft that are sort of taking the tops off the thunderstorm and you know, moving it away from the main development area. An overshooting top, this would be like once that buoyancy, or once all those air parcels kind of reach their equilibrium level at the high levels of the atmosphere, this is where they start to come back down. So I'll show you a picture of this. So we've got the main body of the tower containing the updraft. Where those updrafts stop is where the overshooting top occurs, and then they start to come back down back into the storm. And then the anvil will kind of be on the back where the winds aloft are sort of carrying that material on top of the storm elsewhere, whatever the prevailing wind direction aloft is. Usually if there's a jet stream or something nearby, it would usually carry it in that direction. All right, so rain-free cloud base. So this is going to be below the updraft. So the last image we saw a thunderstorm kind of from a distance. This would be like if you're looking right up into it. So underneath the main tower. So there wouldn't be much rain there because that's where if the updrafts and the downdrafts are separated, that's where the updrafts are going to be. So that's where it's going up into the cloud, not where it's raining. So very little precip falling, you know, like I said, above the towers. A wall cloud would be an isolated lowering of the rain-free base, and it could be rotating, and that could give you clues as to maybe what could be coming. So here's a close-up. Now we're a little bit closer up. We have the storm tower there. We have the rain-free cloud base, kind of that dark overhang there, and then you see this little wall cloud that's sort of kind of hanging lower than the rain-free cloud base. All right, so a severe thunderstorm. This is a storm that produces sustained winds of 58 miles per hour or greater, and or hail 1 inch diameter or larger. This is when we issue a severe thunderstorm warning. This is what we were issuing for. A funnel cloud would be a rotating funnel-shaped cloud extending from a thunderstorm base, but not reaching the ground. So these are some examples of some funnel clouds. When you see these, you want to look for persistence. Is this feature attached to a storm cloud? Is it attached to a wall cloud? Is it in contact with the ground or the water? Or is just kind of floating above? If you see these, definitely report these, because these can be kind of precursors to maybe a water spout or a tornado. But yeah, then I'll kind of get into that here in a little bit as far as what to call in for. But definitely, if you see something like this, that's a funnel cloud. All right, so shelf clouds. These are a broad, flat cloud stretching out ahead of the main storm that forms along the outflow. So this is kind of if you're on the other side. So we were kind of looking more on one side of the storm. Now the shelf cloud is going to be more in the precip area, near the downdrafts. And then a water spout is a violently rotating column of air pendant from a storm cloud over the water. So this would be an example of a shelf cloud. This is, you can kind of see that pointing piece to it. Some people might get a little confused with a wall cloud, but again, this would be kind of on the gust front when the storm is coming towards you. That would be the first thing that you see if you just feel the wind out ahead of it, and then the shelf cloud would be a feature like this, and then the precip would come. If it was moving, if the storm was moving west to east, and you were pretty much right in the line of fire there. So this would be what you would see on ahead of it. Water spout. This would be the rotating funnel out at ahead of in contact with the ground. So when you're seeing these, you obviously want to see if there's any kind of that's touching the ground, if it's there's water, being sprayed around there at the surface. We do get these a lot. I will say the leeward sides of the islands. I showed you the image earlier with the where you're getting convergence around it with southeast blow. You're getting convergence around the island, and then diverging around the island and sort of converging on the leeward side. Kind of similar to where the air is diverging around the mountains, converging on the leeward side, and then you just have some shearing in the wind that kind of creates these little vortices that are more likely to appear on the leeward coasts than on the windward coasts. So that's something to watch out for. Okay. All right. So I guess you guys aren't able to ask questions. I was trying to put this in the. You guys can you guys pull up the chat window and type them in there?
Hey, Matt, this is Kevin Bogan.
Yep.
I did enter a question, but I guess you're not seeing it. My question is, how is the maximum sustained winds value determined?
For which topic? Maximum,
This was a while back. So maximum sustained winds. You talked about sustained winds.
For hurricanes?
Yes.
Okay.
Tropical storms, hurricanes, etc.
Yeah. We're using a number of different things. We're looking at models. We're looking at our polar orbiting satellites that provide a scatterometer, gives us an idea of how strong the winds are based on the wave action. I would say we get information. If it's close enough, we can get Doppler information with the radar. So there are a number of different things, but I would say most of the time, especially from a distance, and if we don't have the aircraft flying into the storm, we're relying on a myriad of different models to use. So we're forecasting not only the track, but we're forecasting intensity.
And it would be sustained for how long? I've heard for 1 minute, so maximum sustained winds for 1 minute, and that's the value used.
Yes.
Thank you.
Yep. Well, I don't know what's going on with the questions. I'm not sure what to say here. I don't know. Kevin, can you try typing in a question? Just see if I'm not sure why I'm not seeing them. Well, let me try something else here.
I typed in the word test.
Okay. Maybe it's not working.
I don't think so.
Okay. Bear with me, folks. I haven't done very many of these. I saw someone with their hand up. I was going to maybe, and I don't know where it went. Somebody was using the hand. Okay. Clement Jung, I'm going to just unmute you here and see if you can talk. Clement, are you there?
Yeah, can you hear me?
Yep, I can hear you.
Yeah, I
you
did
had a
type in a question. When you were talking about the anvil, that picture, that slide, could you perhaps get to that picture? Back it up.
Yep. Mm-hmm.
Okay. Which direction is that main storm tower? Is it moving to the left of this picture or to the right? Which direction?
I'm not sure which direction the storm, if it's kind of, it's kind of hard to tell from the still image. It looks like maybe moving left to right, or maybe coming towards. The only reason why I guess it looks like we're probably south of the storm looking north. And the reason why I say that is because there's this thing called the rear flank downdraft, where you see these kind of absence of clouds on the left side there, kind of coming in. So that's what I would say is we're probably south looking north, and then the storm's probably moving left to right, east to west, or I'm sorry, west to east. And then the anvil would be moving towards the east as well, driven by some kind of jet stream aloft.
And the rain clouds are forming just below the overshoot top to the ground. Is that where the rain is coming down?
A little bit away from it, probably more not under, maybe further away, because the overshooting top is where the updrafts are occurring. So it's more likely that it's kind of up. You see kind of where the hill is and where the building is there. You can kind of see where
that's where the rain's coming down.
Yeah, yeah.
Okay, so the anvil is the direction of the storm. The overshoot top is the tail end of the storm.
Yes, yeah, it would be if you're kind of looking at it like front and behind. Yeah, I guess you could look at it that way. Yes.
Yes. Okay. And so could you go to the other slide after that? Let's say continue on. Continue. Okay. The shelf cloud. Is this cloud approaching us as we view the picture?
I would say yes. It's either approaching us or moving slightly towards the right.
Okay.
The storm would be. Yep.
Storm. Okay.
Yep.
Okay. Thank you.
Yep. You're welcome. Okay. Well, I will. So this will probably be the way I'll do it here is I'll just unmute you guys. Just raise your hand if you guys can see the hand raising. I see some people with question marks. I'm not sure. So hopefully you guys can find the little hand raising thing, and I'll just chime in. There's another thing with question marks here. So let me see if this works. So I'm gonna just call on William Hansen. Let me just, oh, okay, okay. I found your questions. Okay. All right, so my apologies, I just did not have the right window open. So I clicked on the question and now they've all come up. So let me, oh, there's a lot of them. All right, so let me just, okay, well, I apologize. A lot of these have built up here. So let me just kind of work backwards here. Okay, someone asked in terms of smaller islands, referring to all the islands except the big island. Yes, I am. So I'm referring to, that's kind of how we usually, in our discussions and everything, we talk about the big island and the smaller islands. So we're talking about Maui through Kauai. The Atlantic, sorry, let's move this over here. Can you guys, Kevin, can you see the questions? Share it on my screen. No, Kevin, have I shut you
Yeah.
off, Kevin?
No. I don't
Okay,
see any
that
additional
doesn't,
questions in
okay, that
chat
doesn't,
on
okay.
my own. Yeah. No.
Okay, I just didn't know if you were able to see them. Okay, let me just check the ones I've done here. How do I get my spotter number? Okay, we'll get to that. Chesneen, we will talk about how to do the spotter numbers. A couple of comments here. Okay, there are some just technical stuff here. Can we get a PDF of the presentation? Yeah, we'll maybe work out something with Kevin. I just sent him one. I'll try to get that to you. If not, there'll be a recording that we're going to upload on YouTube, and you can kind of watch it again if you need to. Will there be a way to save the chat? I'm not sure about that. Is the splitting of the trades responsible for the lighter winds in Hilo? Yes. What happens when strong solar and active lava, which would increase heat on the land? How would that impact the direction of wind and rain? I will say that with the area, the Kilauea volcano, because of all the heating, I would say it kind of the area over the park there kind of is actually there isn't that much cloud cover that forms over that area. There's kind of it's a little bit of a, I'm not sure. I think that is caused by the just the aerosols released when there's kind of an oversaturation of aerosol SO2 tends to suppress rain a bit. I'm not sure with I'm not sure how to answer the question about the active lava. What time of year do you see the most southeast Kona flow? Winter time, just because the trade winds break down and there's trade winds break down, more fronts approaching. We're just end up in that regime where there's winds coming in from the southeast. Is it really a myth that Maui is protected by Big Island and Haleakala? No, I would say, or that yes, it is a myth. What you could see with Douglas last year, it can easily just come in just to the north or south of the Big Island and impact Maui. Maui is definitely not protected. I guess this person's left already, so. I've seen so many hurricanes aim for Maui and then turn north. On average, what has been the ocean temperature increases? It varies throughout the year. So, I mean, they just go in cycles. So some years they're warmer than others. If we're talking like paleoclimate, I'm not really sure about that. Like, but generally they're going to be, warmer in the summer and fall months, which kind of corresponds with hurricane season, and then cooler in the winter and summer when we get less. Just it's all based on the time of year and how much how direct the sunlight is. So just remember, it takes a while. There's a lag time with the ocean and how much time it takes to kind of reach its maximum temperature before it starts coming back down. Just wondering, is the Kona low responsible for a cause of the Pineapple Express weather on the mainland? If not, curious what causes it to occur. The Pineapple Express. I'm not really sure on that one. I don't think it's the Kona low. Kona low is a fairly rare event. I think the Pineapple Express is more just the jet stream, the upper. It would be probably more of like the summertime upper trough that kind of sits over the islands. It's a U-shaped and then it kind of points in the direction of the west coast. So if that kind of sets up that southwest flow that goes from Hawaii to the mainland. But I don't think a Kona low would be responsible for that. If not, what causes the event to occur? Okay. With tropical cyclones in the last few years, is there a trend they are getting stronger or maintaining strength? There is some correlation with just I mean, it's kind of, again, that's more of a cyclical thing with the Genesis zone with El Nino. If it's just warmer ocean temperatures, they're just, in 2015 when we had the record year, we just had very, very warm oceans. It was El Nino. It was the decadal active phase. There were kind of two phases that were moving in sync with each other. And then there's also another feature that we're looking at, is the Madden-Julian oscillation, which is something like a 30 to 60 day thing which goes around the planet. So a lot of times when these global patterns kind of set up where it just so happens it's our turn where we're going to get really active, and yeah, just kind of things really came together in 2015. So as far as just an overall trend, I'm not sure on that one. But I will say that the active, the 2015 we had, it wasn't like a new normal. It's come down quite a bit. So I think we'll probably have another year where we'll have that many again sometime in the future, and we'll probably have years where we just have like 0 or 1. The Atlantic is forecast to be higher than normal, correct? I didn't see what the Atlantic forecast was today. That's, I guess, something I should have looked at. But that came out just today. And I believe if we're thinking normal to La Nina, that's usually more active for them. So I'm guessing that they would probably be 15 to 18, somewhere around there. That's kind of a little bit above normal for them. Can a tropical cyclone jump from the Atlantic to the Pacific Ocean? I know we've had like some events where it just like over Mexico there, kind of that real narrowest point there, or near Costa Rica. I don't know if I've ever seen one that retains its name. I think usually what happens is they just reclassify it as an East Pacific storm, and then that gives it a different name. But it's a good question. How is the maximum sustained winds? How is maximum sustained winds value determined? Oh, Kevin, that's your question. Just answered that. Does a cool La Nina year mean cooler temperatures overall? That would be no, just mainly in certain parts of the globe. There are some areas that get much warmer or have a drought as a result of La Nina. So not overall global temperatures, but just in that area, it has influences around the world. What type of thunderstorms would cause a flash flood watch or warning? Well, with the warning part, definitely, because that's a short fused product. I would say that, again, having the moisture lift instability shear kind of all coming together and getting like organized type thunderstorms, if they just happen to move over the islands, dropping very intense rainfall, that would be enough to trigger a flash flood warning. For watches, that's a little tougher. Usually we like to see, I mean, it may trigger a watch if it's like a big enough system. Usually with flash flood watches is we like to not just impacting like one island. We usually like to kind of see like a statewide or half the state being impacted, rather than just kind of a small section, or just like if it's unstable on just Kauai and then the rest of the islands are fine. Usually and winter times are our flash flood season, or our wet season, where we tend to have more upper level systems and surface fronts come down and cause that. Thunderstorms are kind of a smaller scale type thing, especially like an individual thunderstorm. But certainly if a thunderstorm formed and it did not move and it was staying over the same area, that would definitely trigger a flash flood warning if it just stayed there long enough and dropped enough rain. Is this a recorded session? Yes, it is. This person asked a long question and then they've left, so I'm not sure if I should answer that. Is the Kona Low responsible for the Pineapple Express? Okay, no, I think that was kind of a similar to the Pineapple Express question. Are you able to see your inbox? Yes. What direction is the anvil moving? Clement, that's your question. I got to that. Is there any particular developments to observe while approaching high elevations? Monica. I'll say just watch, if it's fairly active and you're going up to the, like, say, Mauna Loa, Mauna Kea, Haleakala. I mean, if you're seeing thunderstorms set up, you're unstable enough and the clouds are tall enough where you can get snow. So that would be something to watch out for. Is usually we're not going to issue a winter storm warning for something like convective kind of popcorn type convection, pulse convection, just because the chances of it are going directly over the summit and dropping enough snow is kind of rare. But that would be something to watch out for if you are going up to higher elevations and you're seeing like heavy rain or thunderstorms setting up. Is that you could also get snow, and also to watch out for lightning. Don't get out of your car. I'm going to talk about lightning here in a little bit. Could funnel clouds appear above areas in the city like Honolulu? Yes, they can. In fact, those pictures I showed were taken from Honolulu. Those were just offshore. All right, bunch of people asking, can you see me? I can see you now. All right, lots of people just testing here. Lots of tests. Let me get through all these. Let me just clear them out so I don't see these. Again, I apologize. This is my first time doing a GoToWebinar, so just bear with me. Your audio sometimes goes out for 5 seconds or so. I hope you all can hear me. I'll try to talk slower. Can you clarify how shear is good for thunderstorms but not for tropical cyclones? This is a very good question. Tropical cyclones do not like shear because it pulls the low level and the upper level circulations, pulls it apart. So if you have a, so your winds are going at different, changing direction with height. Say if it's moving, winds are trade winds moving out of the east at the surface and upper level winds are moving out of the west aloft, it's going to essentially pull that apart, and your low level circulation and your convection, your thunderstorms are going to be separated, and the storm's just going to weaken. And I mentioned earlier with thunderstorms, with thunderstorms like shear because it separates the updrafts and the downdrafts. I will give you another example here. Is a lot of times if a tropical cyclone is being sheared and it's being pulled apart, sometimes the thunderstorms will actually fire up, even though the storm is losing its ability to sustain itself. So sometimes we'll see that, or if we've declared the storm post-tropical, extratropical, and then all of a sudden you just see this burst of thunderstorms firing out of it, that's the shear. But overall, we would be, it's hostile for tropical cyclones, good for thunderstorms, or vice versa, whichever way you're looking at it. See, I've witnessed a few waterspouts on the windward side or the east coast on clear days of the Big Island, and they have seemed to be benign and short-lived. Should this be reported? Yeah, you can report it because it gives us a good idea of just the instability, and of course those, I mean, waterspouts can be hazardous to boats, and that would be definitely something reportable and something we would be tracking. So definitely, if you see one, just call it in. We'll probably do a local storm report on it, LSR on it. Sometimes I mentioned earlier they normally form on the leeward side. If you shift the wind direction around, and if we get if we go under southwest winds for a couple days or whatever, you certainly can get them on the windward side, because then the windward side and the leeward sides kind of flip around. So it's certainly possible. I didn't want to make it sound like this was the only, or that was the only side to see them on. SKYWARN card and training. I'll talk about that at the end here. Are we more protected in Kamoela, central part of the Big Island, from hurricanes because of the surrounding mountains? No, because you could get one that comes in from the northeast. You may be protected a little bit from, if from a southeast, from something that's coming from the southeast, but not all tropical cyclones come from that direction. They can come from directly out of the east. It can slip right in there and go right over that area, Kamoela, on the Big Island. Yeah, I don't want to tell people that there's areas that are protected, because there's really not any areas in Hawaii that are completely protected from hurricanes. What caused Lane to just fizzle out? Lane was a victim of a lot of wind shear. So sometimes wind shear it takes it a while to weaken it, but it just, actually, I've never seen up to this point, at least from my working here, a hurricane weaken so quickly. It also wasn't moving that fast. It was kind of stationary, and it was just kind of weakening in place before the low level circulation popped out and it moved directly to the west. So a lot of things in play there. We were watching. We were thinking if it was going to remain as a hurricane, remain as a major hurricane intense, that it was going to still continue on on its path, because it's being steered by the mid-level winds, kind of the culmination of the low level and the high level winds. But if it's getting sheared apart, the low level circulation is being taken over by the trade winds, and it's going to shoot out to the west. So we were kind of watching that but I've never seen one go from like category 4 to 1 in like 24 hours. That was pretty remarkable. But yes, a lot of wind shear. Oceans were certainly, it wasn't approaching any cold water. It was to the south of the islands, and usually that's above 80 degrees. Does the height of Mauna Kea and Mauna Loa influence hurricanes approaching the Big Island? No, there've been a little, I know there was a PhD student here that was studying that. No, it's not gonna deflect it. If a hurricane's approaching, usually, I know the Big Island is big, but the hurricanes are usually much larger. So it's just going to run right into it. And yeah, you might get some protection on the leeward side, but it's not going to, I don't think the mountains themselves are going to stop it from going on its normal course. Does IMPING app data go directly to NWS Honolulu? Yes, I had a slide about that. I didn't really want to talk about it with, because the focus here is SKYWARN. But yes, if you have the IMPING map, we can look at, it'll plot it right on the map. I have a radar loop, and I have IMPING superimposed on it, so I can see in real time when you send the IMPINGs out to us. I can see it right on radar where you're talking about. So yes, keep sending those. Very helpful. Where can we get a field guide? Skywarn.org. There's you can download it for free. I'll post that. It's on my last slide too, but it's just www.skywarn.org. Okay, just a couple. Can you hear you perfectly? Can you report through Twitter? You're certainly welcome to. You can tag us on Twitter. You can hashtag WX report, or you can just at NWS Honolulu. We'll see them. I would say if it's more of an urgent situation and it's something reportable, and then I'll show you that list here. Probably the phone call is probably going to be the fastest way to get to us. But yeah, if you got something that's just here's my temperature today, or here's how much rain I got today, yep, you certainly can report that stuff through Twitter. Last one here was never had one since 1970. I don't know what that is. Okay, so I went through all that. Keep asking away. I've got the window up here, and again, I apologize for not seeing your questions up to this point. I'll see if there's any hands raised. I can do the hand raise thing, so you can if you click the little hands, you can do a question that way. I can unmute you and you can just ask me. Do you rely at all on PWS? I'm not sure what you're talking about, Tim. Maybe I'm just in the right, maybe not in the wrong context here. Personal weather stations. We have co-op sites, so we have people that are volunteers with the Weather Service. I can give you that info if you would like that. Then there's also a thing called cocoa raws, which I think that's probably more what you're asking for people that kind of have their own thing. I'll show you this slide, Tim, when we come to that. Okay. All right. So let me just catch up here. So we're on shelf cloud. Okay. So this is going to be. I answered when I was answering Clinton's question. You kind of wanted to get orientated. What side of the storm are we on here? So if the best way to kind of think of it is the storm is passing west to east, and we're kind of seeing it go from left to right across our field of vision, and we're kind of looking out of south towards the north. So if we do that, the rear flank downdraft, the storm tower, the overshooting top, that's all going to be kind of on the back side of the storm. That's going to come last. The precip side of the storm is going to come first, and that's going to be first where you see you're going to feel the wind out ahead of it, the gust front. You're going to see something that looks like this, a shelf cloud, and then the rain's going to follow, and then the wall cloud, and then the tornado or whatever would be on the back side of that. I'm going to show you pictures of both the shelf and the wall cloud so you don't get them confused. Coming up. All right, so we talked about water spouts. All right, so now we're going to get into another definitions here. We have microburst or downburst. They're kind of synonymous. This is what happens when you have a downdraft with an outrush of damaging wind on or near the ground. So what's happening here is you get your downdraft caused by the raindrops, but then the raindrops are evaporating. Evaporating is a cooling process, and it creates, as you know, cold air is more dense than warm air. It creates cooling of the air and makes it heavier, so it pushes down even faster. And you can kind of see the diagram when it hits the ground, it spreads out and creates these little vortex rings around it. And you can see evidence of that kind of if you see a microburst from a distance. Now, if it's right on top of you, you're not going to see much other than just a bunch of wind, pretty much just hitting you all at once. But this is more common in say the desert Southwest, where you just have really dry air and you have a lot of evaporation occurring as it's coming down. We have pretty moist air here in Hawaii, so it's not a common occurrence, but I guess it can occur. Okay, and then we have a tornado, which is a violently rotating column of air from a thunderstorm and in contact with the ground. So that's kind of the definition, that the difference between a a funnel cloud would be one that's still up in the air. A tornado would be contact with the ground, stirring up debris. But you see the difference here is the air is being converging towards the vortex and then going up versus the downburst, microburst, which is coming down. But they're both going to result in very strong localized wind speeds. So this would be what you'd see if you were to look at a microburst from a distance, and you see these little foot, I guess you call that a little foot that's attached to it here. That's kind of that horizontal vortex ring that's kind of on the outside of it. All right, so this is a tornado. I'm not sure if you can see this. I got a video here. This is from Kula in 2009. So the condensation funnel here, it's kind of hard to tell whether it's in contact with the ground or not. You kind of want to look a little closer to see if you're seeing, debris being stirred up. Kevin Bogan wanted me to reinforce to you guys when you're calling a report for this to just, if call it if it's a funnel cloud or a tornado, just say you've got the funnel cloud and possible touchdown. I mean, you don't want to, you know, if you just do what you can, say at a safe distance to, you know, if it's
And
a funnel
and
cloud
Matt,
or a yeah. Maybe
that
you
would
can
be more when they're doing it on radio. On radio, other people might be listening. If they're calling it on the phone, they can call it what it is, tornado. Thank you.
Okay. Just wanted to make sure I'm saying that right. But thank you for clarifying. All right, so yeah, funnel cloud not in contact with the ground, tornado in contact with the ground. But like I said, the condensation, it may be a little tough because the condensation funnel may not be all the way down to the ground, but you're seeing debris at the surface being stirred up. Obviously the case with the tornado or the Kapolei image here, that's obviously touching the ground and it's stirring up a lot of debris. Okay, shear and tornadoes. Already talked a lot about this already, is where you have the changing of wind with height and it separates your updrafts and downdrafts. Your forward flank downdraft, that would just be kind of your kind of similar to what the position where you're getting the downdrafts caused by the raindrops. So that's going to be all in there, and then it's going to spread out, and that's the wind you feel before a thunderstorm moves over you. So that's kind of the gust front out ahead of it. So it's going to come from that. Your overshooting top, and then you've got your updrafts that go up into that, and then when Clem was asking his question about what side are we looking at, well, this is kind of the same orientation as that image I showed you of the thunderstorm, where you could see that those areas on the back side of the storm where there was not a lot of clouds, and that's due to the cold air the air on the cold side of it kind of wrapping around on the back side of the storm. So you could think of it as, I mean, it's a low, but it's a counterclockwise rotating low, but you've got your air masses that are separated. So the warm side would kind of be on the south or the southeast side, and then this would be the kind of the cold air wrapping around on the north side, kind of much drier air, and that's why you don't see as many clouds. All right, so the tornado process, what are the precursors here? If you see a rotating wall cloud, then a funnel cloud, and then a tornado, usually in that order. What makes the wall cloud possibly tornadic? Watch it. If it's persistent for 10 to 20 minutes and continuing to rotate kind of slowly, you may have to look closely, kind of watch it. So that's why we kind of say watch it for a little bit. If you see persistent, visible, and violent rotation, I mean, that may be a sign that a tornado will be coming. If you start seeing some inflow into it, like it's like the winds are picking up and it's going into the storm, or towards this wall cloud, potentially be a tornado forming. Any kind of rapid vertical motion, it may be a little hard to see vertical motion occurring, but usually that's if you see the clouds kind of, you see the cloud extending down and then sort of forming, that would be the vertical motion, the wind going into that, forming that funnel cloud. All right, so wall cloud versus shelf cloud, again, kind of different parts of the storm. The wall cloud is going to be on the rear part of the storm, on the rain-free base, under the updraft. It's going to point down and towards the precipitation. Shelf clouds are going to be located on the front part of the storm and form as outflow as outflow forms on the storm rushes ahead of the storm tower. Okay, maybe I can word that a little differently. But anyway, on the front part of the storm near the gust front, and these are going to be point down and away from the precipitation. So here is a wall cloud located near the rear flank downdraft and pointing towards the precipitation. Here's a video here. So it definitely has kind of a little distinct point to it, but then it's You kind of see the cloud itself looks like it's kind of maybe slowly rotating as it's, I mean, this is a sped up image, but. Okay, and then here's the shelf cloud. So again, so you kind of see when the point on the other side gets to it. So this would be pointing away from the precipitation, down and away. It's also going to be, because you can kind of see it didn't even fit in the camera engine. They're also going to be, it's also going to be bigger too. The wall cloud should be just kind of a small little section that's extending out of the cloud and rotating. Funnel clouds and tornadoes. So wall funnel clouds, we want to watch them for persistence. Is it maintaining, or is it just kind of your eyes playing tricks on you? It kind of comes and goes away, or you, I'm not sure. But you want to watch for persistence. Does it look like it's maintaining itself? Look very closely. If you start to see like a very slow rotation, that may be evidence that a funnel will pop out of that wall cloud. Funnel cloud should be attached to the wall cloud, so you want to see both of those features together. Tornadoes, the condensation funnel may not touch the ground, but you may see debris at the surface. You want to look for rotation, and is the circulation, is the tornado circulation, is it attached to the cloud? Because if it isn't, it may be something else. Maybe a gustnado, it may be a dust devil. All right, so funnel clouds, more images here. So you can see they're definitely well off the surface there. Here is a tornado life cycle. So this is kind of this is about a minute long. A couple things I want to point out here. Here's your rear flank downdraft here coming on the back. Yep, so there you see the funnel cloud forming, but you can even see in the larger area here, you can kind of see this lowering here and this little point out there, evident of a wall cloud. But you can kind of see even back here, so maybe some rotation going on. All right, so tornado lookalikes. Let's see, we have the gustnado. I mentioned that earlier. If it's not attached to a wall cloud, if it's not on kind of the portion of the storm, if it's out ahead of it, and usually if you call it in and say, hey, it was a tornado, whatever, if we can match it to the radar signature and be able to tell if it was a tornado or kind of like a lookalike, like a gustnado, because it would just be on a different part of the storm. So this would be kind of more on the outflow boundary of the storm. And sometimes you just get these little, it's unstable. You get these little small circulations of rotating air, and these things can form. So gustnado, look for a connection with the storm, and may like I said, may be not associated with the normal structure. Dust devil, you can get these in sunny weather. They may not even occur in any vicinity of storms. In fact, they're most common in like the desert regions where you maybe the only thing, but they can be. You definitely don't want to drive through them or walk through them. They can produce some pretty strong winds. But look for a location within the storm. Circulation can be drawn upwards into a storm becoming a tornado. I guess there's possibilities with that. Here's an example from Kauai High of a gustnado. Kind of see it's not really. You just look at the background. I mean, it's a grainy image, but you can kind of see it's fairly benign. Clouds behind it. Gustnado picture here. Let's see. How big can a wall cloud be? I don't know. Like I said, they're fairly small. I guess it's kind of hard for me to really throw out like a distance or a length of. But usually, I mean, it should kind of. You saw where the angle the videos were being taken. I mean, you should be able to kind of fit it into a camera image. Yeah, I don't really know, but it wouldn't be on the order of magnitude of miles across or anything like that. It would probably be like maybe a quarter mile or something to that effect. I'm not sure. I guess, Kevin, this might be a question for you. Why would you not call it what it is, even on radio? I think she's referring to the tornado or funnel cloud.
Yeah, on the radio we have many different listeners, and the word tornado might cause a panic to those that don't understand what's going on. So that's why we suggest if you're reporting it into SKYWARN ham at the National Weather Service, that you use the word funnel cloud touching the ground as opposed to tornado. I hope that clears it up. Thank you.
Yep, thanks. He says it also gives more warning to people in its path. Are devils common off Saddle Road? That's a good question. I'm not sure. It's not anything we wouldn't be able to pick it up with radar very well there. I don't know. I haven't driven across Saddle Road enough to see them. I would say it's fairly dry there. It's just the topography with Mauna Kea and Mauna Loa right there, and I would say it would be a place you could definitely get them. I'm not sure how common they are though. That'd be a good question for someone that makes that commute every day. But it's like I said, we haven't gotten very many reports of them if they are occurring. No one's calling it in to tell us. But good question there, Laura. Okay. Guess a comment here, maybe mistaken them for military training. I don't know, could be. Okay. That's all the questions I have. All right. So non-tornado threats. So we have microburst, mentioned that earlier, where you have the winds or the raindrops evaporating and sort of creating this more intense downdraft and hitting the ground at a very intense and then spreading out. So these damaging winds can be produced within a thunderstorm. Speeds can exceed 100 miles per hour, for a very short burst, maybe 10, 20 seconds, but it can, knock down trees, take out power lines, damage homes. It can, do a lot. Like I said, wind swaths usually less than 2.5 miles wide. Hail is chunks of ice formed within a storm due to intense updrafts. The largest hailstone was over 11 inches in diameter. So here's kind of the setup for a microburst. Again, cool, moist air moving into this area of warmer, drier air. It evaporates and creates a more intense downdraft. Here's a video. So this will be the perspective of being right underneath one. Yeah, so again, you had the, okay, yeah, there's another perspective here from a distance. There's that little rain foot thing, that circulation, then the downdraft there. You can kind of see both their images there. All right, some microburst summaries. Watch for large bursts of cloud precipitation descending from a thunderstorm. A rain foot indicates the winds are descending to the surface and then spreading out laterally. Report them as quickly as they are difficult to forecast, warn for. As you can probably imagine, these are going to come and go away faster than our radar scan is going to get to us, and for us to crank out the warning. So, if you do experience one of these or see it from a distance, report those. We may, because there may be others that are out there. It's usually a lot of times if we have like a evidence of something like that happening, then we'll probably be a little more like, okay, this is already occurring, may occur again. We're going to be on the watch out for it then. But definitely a very, very small micro scale thing to look for. All right, so here is the hail formation. This is a kind of a sheared environment here, but what's happening here is the updrafts go up into the ice formation of the cloud, forms the ice. The ice falls out of the cloud, but then it gets it's too light to fall all the way to the ground, and it just gets sucked back up into the updraft and goes back higher up into the cloud where it freezes again. So even though this original hail growth zone, it may come down, it's going to melt. If it was to make it all the way down, it might have melted and just fall as rain by the time it got to the surface. But since it's able to create these additional coats on top of it and grow larger, when it finally falls to the ground, so it goes back up into the cloud with the updraft, and then when it's too heavy, it falls down to the ground, but then it's not able to melt by the time it gets to the surface. So even though it's a warm summer day, and then you might get ice falling out of the sky as a result because of this process. So yeah, large hail falls out. Here was our hailstone from 2012. This is the one that also brought that EF0 tornado that came across Kaneohe and Kailua. Damaged a few homes there in Lanikai area, and also dropped this hailstone right near the Marine Corps base entrance there. So that was our state record of 4 inches. And yeah, it looks like a lot of little ones glued together, but that's generally how they form, is they're smaller, and then they get additional coats, and then maybe they stick there because they have that wet coat on them, and then they freeze. It just creates kind of a larger conglomerate of a bunch of small hailstones. So that is the largest hailstone for Hawaii. This would be what you're seeing from a hail shaft. This would be from a distance. You kind of see just all that kind of white colorish, just all that hail falling. So this would be kind of one from a distance. I guess it'd be very hard well, not very hard, but I mean, this would be something that may not seem obvious from a distance, but when you maybe take a close look at it and go, oh, that's probably getting, hail in this area, if it's a very intense thunderstorms. Usually if we're looking at radar, usually the highest it's going to be a very high reflectivity for us for hail. So if we could match that up with your report from, even though it may not be falling right on you, that would be that would be helpful. So here is underneath, and I don't think this has sound, but this is just very large hail falling into a swimming pool. No, that was a very short video too. Yeah. All right, reporting hail, if possible, measure it with a ruler, get the diameter. When describing hail, if you don't, not everyone carries a ruler with them all the time, I understand. But if you're describing it, use common objects like pennies, nickels, quarters, golf balls, baseballs. It also helps if maybe you take a photo and it's next to one of these objects that have like a common size. That's also helpful too. And also when you're reporting hail, report the largest one that's fallen in your area. But don't go out and hurt yourself over it. Just, you know, just if you've got a bunch of hailstones in front of you, you just want to report the largest one. And then here's kind of our comparisons. This is kind of the usual Weather Service translation for these common objects, what they would translate to. So our severe criteria would be 1 inch, which is quarter size. And so if you can compare it to a quarter, that would be technically severe hail if you get that. And yeah, and don't use marbles because marbles can be all different size. Okay, I'll stop here for some questions before we get into safety. I've seen a few dust devils in Waikoloa a few times. Okay, thanks. That would be yeah, another area, I guess. I mean, you can kind of get them anywhere, so that's not surprising. Dust devils are frequent along H19 from 82 to 87 mile marker, infrequent along Saddle Road. Okay, so you know you must drive that route, John. So yeah, I'm not surprised with just all the topography on, just the mountain effects on the Big Island, seeing that you just kind of have all the different volcanoes, and just like I said, the diverging of winds around the Big Island and converging on the leeward side, and the sea breeze effects. Remember, the sea breezes come from the west, the trade winds come from the east. It doesn't take much to get these circulations develop. So yeah, I wouldn't be surprised if the dust devils are forming in those areas, but please call them in. Do you need to join SKYWARN ham? No, you do not have to be a ham operator to join SKYWARN. You can, at the end, I'm going to give you a phone number, and you can call that number and talk to the forecaster here. Is microburst only formed during thunderstorms? Usually, yeah. I mean, at least the ones I'm kind of referring to. I mean, you can get any kind of strong wind gusts, but the ones that are kind of associated with thunderstorms would be a microburst. Is it true the government is experimenting with creating alternate weather patterns? Cannot answer that question. I'm joking. I don't know. Experimenting. I mean, I know they do for like airports. They'll do like cloud seeding to cloud seeding to get rid of like fog and over like airports, so they can get the planes in. I've also heard that they do things where they're also seeding the clouds to make rain, to get areas that are under drought. I'm not sure if it's the government or like like maybe it's like a research like from a university. I mean, they're always doing kind of weather experiments. But yeah, I don't know about alternating weather patterns if it's going that far, but certainly maybe to seed the clouds to get, you know, rain on their crops and stuff. I don't want to get too much into that. Let's see, hail. I had some property damage from the hail. Let me just move this over here. I had some property damage from the hail in Kailua Marine Corps Base in 2012. What type of conditions would precede a hail event? Low pressure, overshooting top. You would want kind of all those 4 ingredients coming together, the moisture, lift, instability, and shear. If you don't have shear, the thunderstorms are going to be more pulsy, and you may not even need shear. Shear's not, if you could have none or maybe just a little bit, but you definitely need something where you have some separation, but you want the ice to fall back into the updraft. So that's kind of similar to what I was talking about with the ordinary cells or like the pulsing cells. So it definitely gets high enough where it's reaching the ice in the cloud. The ice falls out, falls back into the updraft, and then goes back into the cloud. So yeah, I would say just a upper low, you know, creating the instability, moisture at the surface, good moisture, and then either like a light wind day where you're getting the sea breeze convergence over the islands. I would say just those 3 ingredients would be enough for hail to occur. It's pretty rare for the thunderstorms to get that high though in Hawaii. A lot of times we may just get right on the cusp of that, but you definitely need some unstable converging lift and moisture to work with. So I would say those 3 ingredients. I noticed on radar too, a lot of hail will occur over the waters, and you know, when there's no way we're going to get a report, it'll be 30 miles off the coast, and it's almost like it might as well not have happened because there's no way we're going to get a report with that. So I would think it's more common than we hear about, but just because it's occurring over where no people are. How long would conditions need to last for hail to occur? Well, you need the thunderstorm to develop and kind of reach that mature stage. And yeah, I don't know. I mean, how long would it take? How long would conditions need to last? I'm not sure I can really put a time on that. It would just be like the right conditions need to be conducive for it, and then it'll just kind of set up and go. I'm not sure if there's a time constraint on it. Cloud seeding, they can read it on Project Storm Fury on Wikipedia. It was canceled after 1971. It was a complete failure to weaken tropical cyclones. Thanks, Liz. Project Storm Fury on Wikipedia, if you want to dive down the rabbit hole about cloud seeding. Why is Kahului in central Maui so windy? Kahului is a windy spot because it sits in between 2 mountain ranges, Haleakala and the West Maui Mountains, and the wind is funneled through a relatively narrow channel, the Central Valley there, and it just accelerates through that. So can't think of the physics principle, but if you have like a large area of air and then it's kind of getting funneled through a really narrow corridor and then back out, so the wind accelerates in the because it's kind of squeezed between those 2 mountain ranges. Okay. Venturi, big picture question: is the 7,000 inversion layer, is the 7,000 foot inversion layer causes, is it temperature from height, the source, or a factor of winds such as the trade wind pattern? It is from the compression caused by the subtropical high. So you have less of an influence than you do, say, in the Bay Area, where it's right underneath it. But we are only about 600 miles south of that high pressure. We usually have like a ridge that's near us. But yeah, we're getting some subsidence that's occurring aloft, and it sort of stops right at that 7,000 foot range. There's less of an influence than it is right underneath it, but so we're kind of positioned a third of the way between the equator and 30 north, and we have some influence for it, but it's not as strong as, say, in the Bay Area. Is Kahului an example of convergence? I'm not entirely sure what that means. Timothy, could you just convergence of air, I guess? I guess. Yeah, I'm not sure on that, Timothy. Venturi is the name. Oh, is the name of the effect you're looking for? Okay, thanks, David. That he was talking about the speeding up the winds between Kahului there, or between the Central Valley, the Venturi. I was talking about the physics principle Venturi effect. So thank you, David. Convergence of air. Yes, I guess you could think of it that is you've got the gradient is kind of pushing the wind at a certain speed. If the islands were not there, it would be just kind of be this uniform wind flow. But then we have the effect of the mountains where it's kind of converging there, right in that area where the kind of where Kahalui's at, and then going through the Central Valley, and then diverging once it gets to the southern end of gets to like Ma'alaya Bay, and then it starts spreading out again. So yes, that would be an example of that, Timothy. 20 minutes remaining. Okay, well, I better get going then. All right, we're getting close here. Try not to hold you guys up too much, but thanks for keeping me on time. I don't want to hold people late, so I can I'll move a little quicker, but if I got to skip a few slides, I'll do that. All right, so safety. So this is, bottom line with this is we like your reports. We appreciate them very much, but don't put yourself in harm's way. Tornadoes, pretty self-explanatory. You don't want to put yourself right in the path of it. You want to seek shelter in the lowest place possible, preferable in a sturdy structure. If you're outside on the ground, or if you're outside, lie flat on the ground or in a ditch, just watch out for flash flooding with that. You don't want to drown, resulting in trying to protect yourself from a tornado. Basements, I mean, I know there's not a lot of basements in Hawaii, but get to a bathroom somewhere which is not a lot of windows. In a rural location, it's been our recommendation to drive if you're in a rural location when you're not going to be stuck in traffic. Don't try to do this in an urban area because you're not going to be able to get through it, and you're not going to be able to get out of the way, and you're going to be stuck in your car. Lightning safety. I know this is a really busy slide, but I think lightning, this is pretty important because I think lightning catches people off guard in Hawaii a lot, and I want to kind of emphasize this. If you're outside, no place is technically safe if there is lightning nearby. You do not have to have a thunderstorm right over you to get struck. It can 10 miles, 15 miles, it can get you from a distance. The best option would be to go indoors. You want to stay off the phone and other electronics, because anything that's connected to the electrical grid, if struck by lightning, and then you're holding the object, it's gonna be electrified and you're gonna get shocked, or more than that. Stay away from plumbing and metal fixtures. I can tell you the story about on Maui. This is like in 2010 or 2011 that lightning struck a house. It wasn't the house. It stuck somewhere in the yard, and it went into the plumbing, or it went into the pipes below ground. And someone tried to turn on their water that was electrified pipes, and they got pushed. They got thrown back as a result of that. So you don't want to be touching metal objects. Seemingly things that you may not think would be safe. You want to stay away from that. Similarly, I kind of stay away from windows and doors, and don't lean or lie on concrete walls and floors for the same reason. You've got electrical wires running through the walls of your house, and if those become electrified,
Matt,
Yes.
one last thing for lightning, especially for amateur radio operators, antenna safety, you have to watch out. You say about 10 to 15 miles. So we need to be taking care of the antenna prior to that, not when it's right on top of us. Thank you.
Right. Yep. That being said, if you are in a car, I know there's a lot of ham operators that are, have it in their cars. You should be safe in a vehicle, assuming that it's a metal top, with the windows up. So that's the Faraday cage. Essentially, if you were in a car, if lightning strikes the car, it's going to go around you and be grounded that way, rather than through you. You want to lean back in your seat. Don't touch anything until the storm passes. You definitely don't want to get out of your car if it's been struck, because you might get, then you're not protected and you might get stuck, or you might get struck then. So you just want to pull over with your hazard lights on if you're driving. That's usually the best way to wait it out, or pull over where you can get in, or stop somewhere where you can get inside. But that would be the second best option. Now, if you're caught outside with no shelter nearby, you want to get off the elevated areas. The worst place you can be is on top of a hill, on top of a mountain, or a peak, where you're the highest thing around, where you're the highest relative to everywhere around you. You want to get in a relatively low ground, such as a valley or a ravine. You don't want to shelter under an isolated tree, again, similarly, because you're attracted by the tallest object in a large area. So you don't, a single tree. You don't want to use a cliff or cave entrance or rocky overhang, because if the lightning strikes that taller, or strikes the elevated area, the top of the cliff, it's going to find its way down to the ground either way. So if you're down at the bottom, those volts are going to spread out, downward as well as across. You want to get away from water. Water is a great conductor of electricity. If you get caught in the, this is definitely, if you're surfing or out swimming, you definitely don't want to be in that, because you're going to get, if lightning strikes the water, it's going to spread out, and then you're going to get caught in the current. Metal objects, you definitely, there's always the, you don't want to be golfing and holding your metal clubs up. But also stay away from, barbed wire fences, power lines, anything like that, because metal can transfer that electricity. If you're the best, I guess the best thing you can do is just curl yourself into a ball. Like I said, I think the best thing to do would be get into the relatively low ground first. As a last resort, curl yourself into a ball. What you want to do is keep your feet together and never lie flat on the ground. And this is Reason being is this image here shows the people and the cow, is showing how lightning dissipates as it goes into the ground. The voltage, what you don't want to have is in the case with the cow where you have a much higher difference in voltage between the front legs and the back legs, because it's going to go in, it's in the front and out the back. So if your legs are far apart, there's going to be a greater difference in voltage than if your legs were together. So that's what the step voltage, that's what it refers to. So the potential difference between those as it goes into ground. There's also the side flash. This is when the lightning goes to ground, but then there's kind of a side part that finds an additional path to ground. So if there's like two trees next to each other, it may jump to the second tree, and then both of them would be paths to ground. Touch voltage would be the metal object. So if you're touching something that's metal that gets struck by lightning. The stream currents, this is the invisible thing you can't see. What you see is the return strike. So these are the streamer currents. I have an image on the next slide that shows that in a very fast motion camera. And actually the lowest amount there is the direct strike. So you can see all these other ones are much higher percentages of people that get injured from that. And it's not even just the people that get killed. There are a lot of people that deal with lifelong debilitating injuries as well as a result of a lightning strike. So just because you survive it doesn't mean you're going to have. So bottom line is to do whatever you can to avoid it. And these are kind of the breakdown with the way that it's done. This video here was from our Science Operations Officer, Bob Ballard, when he was out storm chasing. Oops, it's not gonna go. Oh, there it goes. So this is the electrified fence. So it's a really quick video, but if you look at this area, this little green fence here and the little triangle, there's a little spark. I'll play it again. But if you look at this little area where there's a little triangle, you see the spark after the lightning goes. Yeah, this is really quick. But yeah, that would be an electrified fence. This thing was Tim Samaras. He took this very fast, I guess it's be a very slow image of a lightning strike. So this is the part you don't see, and then the part you do see is the return strike. So it's actually coming from the ground up into the sky. So that would be an example of the stream current that I mentioned on the last slide. Okay, flood safety. I want to emphasize this one too because this is a very important, big impact to Hawaii. So never drive across a flooded roadway. There's surprisingly how little amount of water on the road can pretty much cause you to lose all control of your vehicle. So, and when you're looking at it, especially if it's usually going to be murky brown water, you're not going to be able to see how deep it is. So it's just don't even put yourself at risk. It's not worth it. Especially here in Hawaii, it's not like the flooding usually goes away in a couple hours, or you can always get to where you're going eventually. But yeah, don't put yourself at risk with that. If the car stalls in the water, leave it, seek higher ground, because it's gonna carry you and go wherever the water is going. You want to avoid low-lying areas, especially near streams, near coastal areas. If there's coastal flooding occurring associated with, let's say, a hurricane or tsunami. Remember that water can rise rapidly and the current is stronger than you think, and it can also occur out of the heavy rain zone. So that would be if the rain's falling over the mountains, it can come down to those narrow streams and cause flooding downstream. This image here is an example from the remnants of Darby when it came across Oahu. Maybe you guys remember all those cars on H1 that flooded out there. And and then it can undercut roads, buildings, houses, and you can get these sinkholes that open up as a result. So just driving during flash flooding is just not something you should do. Hail safety, this one's kind of self-explanatory. You just get inside a sturdy structure. Cars will usually be sufficient until it reaches golf ball size. And here's an example of that. You see it's already broken their windshield. Yeah. Yeah, it can, it gets that big, it's gonna hurt. So yeah, just pretty self-explanatory. Get into somewhere where you're gonna be protected. Hurricane safety. So you want to prepare your home ahead of time. There's a free homeowner's handbook at this website that you can use to prepare your home. This is where I was going to try to use the messaging. Let me see. Oh, no. Because I wanted to give you guys the link here. Okay, it should be on the chat. Hopefully you guys are able to get the chats, even though I wasn't getting you guys' comments. But that'll be on there for you. It's just a free, it's a PDF of a free book you can download to get your home prepared. But you want to have adequate supplies. The recommendation is 14 days in case you lose power, water, not able to leave due to flooding or blocked roads. Know where you'll be going during the storm and communicate that to family and friends, just in case communication is lost and you can't, then they can't reach you. Put together a go bag, disaster supply kit, flashlight, batteries, cash, first aid, medications, copies of your critical information in case you need to evacuate. As far as evacuations go, check with your county emergency management agency for shelter info if you plan to use those. Those are county run. You want to stay up to date on what's going on with the latest on the hurricanes. Check our website, weather.gov/HFO. Of course, you can use local media, radio stations, no weather radio. If everything else goes down, that's still going to be broadcasting. H&L Info, that's the Oahu app that has a more has a more comprehensive list of all the of our products, and then as well as like all the stuff that comes from the emergency managers. All right, and then know what zone you're in. Oops. Yeah. Just gonna post this in there. So these links here are gonna be the maps for tsunamis. And then flooding. So what flood zone are you in? So tsunami, what the tsunami zone, and then there's like a regular tsunami, and there's like an extreme one. Flood zone is going to be, usually your flood insurance. It's going to be based on that. And then storm surge, this would be for for hurricanes, for storm surge from hurricanes, what impacts will be felt. So you can overlay this stuff and figure out where you know, compare it to where you live, your place of business, where you're going to be going. So helpful links here. So, but it's important to know where your hazard zone is. All right, and then so those are your tropical cyclone impacts, and then finally wind. Obviously, that's going to the strong winds can occur anywhere with a hurricane. Higher elevation, exposed areas, downsloped areas are more prone to localized winds and gusts, stronger than the maximum sustained winds of a hurricane. So just keep that in mind. If a hurricane is a 100-mile-an-hour max sustained winds, you could get some localized effects due to the mountains, the island effects, and the kind of what we talked about with like Kahului converging and the acceleration through the Central Valley. You're going to get some stronger gusts. Idle info from slide 60. You jump to slide. So there's Wayne, you asked a question about why I jumped. There were some other slides in here that I'm definitely not going to have time for. So I tried to hit the main points and kind of get you spun up, but a lot of it was kind of saying the same thing again. So apologize, I didn't take them out. I was maybe going to use them at another point, but yep. So that's the reason for that. But no, I didn't skip any. Okay, so wireless emergency alerts. These are the automated phone ones that alert. As you can see, the list isn't very long. So these are going to be like the big ones, the hurricane warnings, the tornado warnings. Severe thunderstorm isn't even on here. Flash flood warning is on here, but it's only for, we now have 3 categories of that. And just the run-of-the-mill flash flood warnings are not, but until we get to like a considerable or a catastrophic type event, your phone will alert. So again, you can use these apps, the Maka'ala for Maui, the HNL info is helpful. You can always use our website, hurricanes.gov, to get the latest storm info. Just remember that they're going to be tracking the storm, not really so much the impacts to you. They're just going to be giving you the latest and greatest on the storm. Of course, local media, you can follow us on Facebook and Twitter, and of course the No Weather Radio, if all else fails. All right, I'm running a little over here, but now I'm just going to talk about, I'm going to skip this slide. This is just kind of the SKYWARN history. But I just want to talk to you guys about what your role as a spotter would be. You're going to just relay information about hazardous weather during events. They provide information to verify watches, warnings, and advisory. And they also give us a real-time like observation of what's going on. I mentioned that earlier with the microbursts. Call it in, because then we're going to be, I mean, we're watching anyway for them, but you know, if we see a microburst, or if you guys call in a microburst or a hail or whatever, we're going to be, you know, we're going to be watching that, or especially for like flooding. You know, if we see evidence of flooding, usually start there and then maybe move somewhere else. So yeah, it also helps create a historical record of hazardous weather events. Okay, just a couple more slides here. How and what to report. We have a tornado, waterspout, funnel cloud, a rotating wall cloud, storm structure, or any kind of storm structure you see, like we were talking about with the anvil or overshooting top or rear flank downdraft. Damage from strong winds. This will be a little more obvious if you see like trees down, power lines down, structures blown down, roofs blown off, those types of things. Damage from flash flooding. This would include structural damage from water inundation, a road washed out, coastal wave run up. So this is also not just the heavy rain, thunderstorm. This could be from, say, a tropical cyclone, large surf event, tsunami. Those are all types of things that could cause coastal wave run up and cause damage. Any kind of sinkholes or erosion occurring, significant rainfall rates. If you've got a rain gauge at your home, if you've got like a rain rate, those are usually more helpful than rain amounts. So if you get measure over an hour or two and you get a certain amount of rain rates, that's usually helpful. That's usually what's going to be more helpful for determining flash flooding, is how much rain is falling in a short amount of time. Visibility less than a mile and snow. I know that doesn't occur too much here, but if you do get, if you just happen to be up in the high elevations and you do get snow, definitely report it.
Say,
Doesn't
Matt,
happen. Yes.
for blown roof, the address of the blown roof would help in the report. Thank you.
Yes. Yeah. Location. So when you, I think my next slide was okay. Well, anyway, when you sign up to become a spotter, you'll give us your address wherever you're going to be located. If you just say, okay, I'm at my normal location, I'm at home, whatever, we'll have that, and we can plot that on a map and figure out where you're at. If you're at a location that's not your home, then yeah, you definitely want to specify that. So if you live in Makawao and you're down in Kahului for the day and you want to call something in, you don't have to be at home to do that. You can just call from Kahului and say, this is what I see here. So yeah, you want to specify if you're at home or you're at another location separate. Okay. Reports, what to do. So what you want to do is either if you're a ham radio operator, you'll be talking to when we activate SKYWARN, and Kevin and whoever's going to be working the SKYWARN desk will be talking to you from our office. Or if you are not a ham operator, you can call our number. There's the numbers listed. We have a primary and a secondary. Just keep in mind, this is just for reporting only, not for if you have a question about the forecast or something. If you could just please call our normal line. It's a public number, 808-973-5286. And then there's an option there in the phone tree to just talk to a forecaster. So we like to keep that separate, especially if there's a lot of active weather going on. You want to, yes.
I was told that if the folks are on Oahu, it might be best to use the 808 number first, and those from the neighbor islands, in order to not have a charge, would use the 800 number. Is that correct?
That's fine. It's whatever you prefer. Eventually, we're all going to have to use 808 anyway, right? But no, if that's fine. If you want the outer islands or non-Oahu to use 800, if you have a cell phone or if the long distance thing doesn't matter. Yeah, you do whatever you like. There's two numbers there for you, so they are listed. So you want to give your name, your spotter number, and location, then what, where, when, and what it's doing now. You want to kind of be brief and concise. Just here as an example, hi, National Weather Service, how can I help you today? Hi, my name's Jason Smith. I'm spotter number 715. I'm calling in a report of heavy rain at my house in Pearl City. It started about 30 minutes ago. I see my rain gauge that I've already have 1 inch, so that gives us a good rain rate to work with. Also, the streams are forming on the side of the street, so that gives us an indication that ponding is occurring. Okay, we see some showers above you on radar. Thanks for letting us know the rate of rainfall, and thanks for your report. Simple as that. I mentioned earlier with the plot, if you just give us your address, we can plot them on a map such as this, and we can observe real-time radar with what's going on with your report. So it's almost instantaneous. If you do submit a report to us. If it's, if we'll obviously review these and look at things, but we'll send out these local storm reports. These will be posted on our website, and you may get your report official. So those are an example of some of the local storm reports that we've issued in the past. Okay, if you want to sign up, if you can go, so I know some of you, sent me your information, and I didn't realize how many people would be signing up. Or how many people would be registering. And then instead of having everyone email me, and it would just take me a long time, I did it this way, where we filled out where I'm gonna have you guys fill out just a few questions on this Google form. And then there's several of us that can go through that and update our database. And then for new spotters, it'll be quicker. That'll be a quicker turnaround for you to get your number. So I'll just post this in the chat. So just click on that link. It'll take you to just a series of questions. It'll just say what your name, address, all that. And here, I'll even show it to you. So it'll look like this. So if you sent me your information already, if you don't mind, if you can fill this out, because then like multiple. So some of the questions are optional, like ham call sign, and then some of them are required. So you just go through that, and if you can't find your latitude, longitude of your house, that's fine. We can find that up on Google. But if you're savvy with Google Earth, that would really help us out too. And then just the date of your training. So if you could just send that to us, and that will make it faster for us to kind of go through all the spotters. Yes.
I just clicked on it, and it still shows you need permission. The form can only be viewed by users in the owner's organization.
On the did you click it in the chat?
Yes.
Okay. I'm seeing a lot of other people are. I tested it out.
But you're in the organization.
Yeah, I know. Well, I don't want to hold people up and try to fix this right now. Let me. I don't know why that's not working. I don't want to like hold people up here, but I'll try to fix this. If it doesn't, if I can't get it to work, alternatively, just send me an email. I was trying to avoid this part, just because I don't want to get too backed up in the number of people. But this is my email address. I know a couple of people already sent me. It's not really my email address. Matthew.j.foster@noaa.gov. You can just send me an email with that information here. Just your name, home address, ham call sign. I'll leave this up for a few minutes so you guys can copy that down. Alternatively, you can send Gavin or Ian there's 3 of us that kind of work on this SKYWARN team. So there you go. There's my email. So yeah, if you could just send that information to me, and then okay, I think some people are trying to help me with this. Let me finish up here. I appreciate everyone's time and attention. Let me try to see if I can fix this, and I'm going to stop recording here.